Hi all, welcome to our YouTube channel. I am Krishna Hariharan. I'm working as a data scientist in one of a reputed multinational company. Be it a data scientist or be it a software developer, so having a strong catch over data structures and algorithm is very vital. And today, to strengthen our data structures, we are solving one of the LeetCode problems that is very popular among top companies, top fan companies. The one such problem is two-sum array where the input is sorted. So come, let's go through the problem statement now. Going through the problem statement, so basically we'll be provided with an one-dimensional array that is already sorted. I understand here there are things that are in bold are pretty important, but when you face in a real-time situation in an interview, they are not guaranteed that you will be given and you will be hinted like this. So important to observe things. One is a one-dimensional array, other one it is sorted. Sorted is such a key role, and I'll tell you why as we go proceed further to solve this problem. So the task is we have to find two numbers such that they add up to a specific target. So we will have an one-dimensional array, and that one-dimensional array will have n numbers. And when you add any one of the two of those numbers, that will add to a target number. So the what is expected to be returned is two indexes whose the numbers in that indexes when it is being added up, it will get on to the target length. So here is another keyword. The tests are generated such that there is exactly one solution. So you may not use the same element twice. So here is a input example. I can see 2, 7, 11, 15 and the target is 9 and the output is expected to be a list or an array you could say with the indices of the specific elements which added to the target. And with respect to constraints, here is the constraints. So the number of length is going to be within this and the numbers are going to be between minus 1000 to 1000. So it is important to understand that there will be some negative values as well. And number is a non-decreasing order. Non-decreasing order is the sense it will start from the minimum and go until the maximum. So for this, let's try to solve it and try to find a solution for this. First, let's go to the whiteboard and get a fair understanding of what is exactly required. So we have a two-sum problem and array is counted. So let's take an example. Let's take an example. So example is input is gonna be 2, 7, 9, 15. And output is gonna target or output, whatever you call. Target is gonna be 9. So here the number of elements that is going to be in this array is not constant. So it's important that we measure the number based on whatever the input it can be. So the target here to solve this problem, what first we'll try to understand it, what is exactly required. So what they're expecting is we have to find the indices of two numbers such that the number in that indices when added will give us the target. For example, let's say 2 plus 7 is equal to 9. Then the output of this program is expected to be 1 and the 2. 1 corresponds to the first element, 2 corresponds to the second element. This is the expectation from the this is what is expected as an output. And it is important to understand this array is sorted. It starts from the lowest number, which is 2, and it goes and it increases step by step, and on the extreme on the right is the highest number. This sorted array, understanding that the array is sorted is the most crucial thing. This two sum comes in two variant. One is a sorted array, other one is an unsorted array. Sorted array makes it far easier because we'll use a specific pattern that will make it easier. So instead of going around with the brute force problems and all solutions and all this, I'll directly tell you what exactly how we are gonna solve this problem. So when you are trying to solve a DSA problem, there is something called as patterns. So there are multiple patterns using which multiple problems could be solved. There are around 15 to 20 patterns. One such pattern in among the 15 to 20 of to solving this two sum pattern especially is it is called as two pointer. So as the name suggests, two pointer is fairly simple. You have two pointers, one point to one element of the array and the second one point to another element of the array. And using this two pointer technique, we'll try to solve this problem. So this is the strategy, this is the pattern. So as we practice day by day, when a problem is given, the developers should be able to identify which pattern will suit it first. The moment you understand, capture which pattern is right, and everything is just a cake. So let's say Let's choose what 2 pattern does. I'll tell you that. So take this example itself, 2, 7, 9, 15. We have to initiate 2 pointers in such a way. Let's say you're initiating here, 2 plus 7. Here, when you add these two, you get 9. You will return easily because here they are adjacent to each other. Let's say we have another problem where 7 is in last. So in such case, what will happen is having an adjacent thing will increase the number of repetition that you go through, number of times you go through the loops when you have 2 pointers that is adjacent to each other. The hint here, as I said earlier, is that it is already sorted. So since it is already sorted, what we are going to do is we are going to declare 2 pointers, one pointer starting at the first element of the array and the second pointer pointing at the end of the array. So the other way to put it is the first pointer will be first at the least element of all the elements in the array, and the second pointer will be pointing at the highest element out of all the elements in the array. And what we will try to do is we'll try to add these two. So 20 plus 15. So 20 plus 15, if you add, it is coming into 17. So but our target is what? Target is 9. In such case, if you see 17, when you compare 17 and 19, 17 is greater or 17 is less. 17 is greater than 9, which indirectly means that if 17 is greater than 9, which indirectly means that, or directly means that, when you add 2 and 15, it is leading to a number which is greater than greater than the target, which means that we need to reduce the highest element so that we can see whether it is meeting the target. So which pointer is meeting at the highest element? The second pointer, which is pointing at the highest element. So what we will do, we'll have 2, 7, 9 and 15. The first pointer will stay in the same place. Since it is higher, this will come decrement by 1. So it will be here. So now we have 2 pointers. What they are pointing to? 2 and 9. 2 and 9 again lead to what? 7. Say 2 and 9 again lead to what? 11. Is 11 greater than 9? Yes. Again 11 is greater than 9. So again we repeat the process. So we say 2, 7, 9 and 15. Instead of, again the 2 will be same, pointing the same here. But instead of 9, we decremented one more and it point to 7. Now you add 2 plus 7. 2 plus 7 is equal to 9, which is equal to target. Yes, it is equal to target. When the target is met, what we do, we take the index position of these two numbers. What is the index position of these two numbers? Index position of this is 1, index position of these 2. This will be written in the form of an array or a list. This is the output for us. So let's take one more example for us to understand better, because here if you see you might not have a misunderstanding that 2 pointer is all about moving the rightmost pointer step by step. There is more ways to it. Let's take one more example so that we understand it better. Let's say okay, here we are not getting anything. Okay, we'll take the same number. Let's say 2, 3, 7, 9. And let's say the target is going to be, output that is expected is going to be 16. So in such case, what we will do, again as say, we will say declare 1 here, declare 1 here, then we'll add 2 plus 9. 2 plus 9 is equal to 11. So 11 is greater than 16 or 16, sorry, I'll rectify, 16. 11 is greater than 16 or less than 16. It's less than 16. In such case, what we know, we are not supposed to move the second pointer towards the left. That's not we are supposed to do, because 11 is lesser than 16, which means we need to increase one number in such a way that it goes close to 16. So we'll move the left pointer by one step. So in the next step, what we will do, 2, 3, 7 and 9. This second pointer will stay in 9 only. The first pointer will move from 2 to 3, and you will do 9 plus 3. Again, 9 plus 3 is equal to 12, which is less than 16 or greater than 16. Again, less than 16. Again, what you will do, again what we can do is, again we'll say 2, 3, 7, 9. Again the pointer is going to be, the second pointer is going to be the same place. The first pointer, we move from 3 to 7. So there are 2 pointers now. So 7 plus 9, as expected, it leads to 16, which is our target. So what is the position of these two? This is going to be 1, 2, third, and 9 is going to be 3. So 3 and 4. 3 and 4 will be the output. I hope you understand it very clear. And let's do one thing. Let's write a basic pseudocode for solving this problem. Let me erase all this a little space. Let's clear out a little space for ourselves so that we will be able to solve it better. So pseudocode is very simple. I'll just, whatever I explained it now, I'll put it in little English words so that that can be a reference or that can be a template for us to solve. So pseudocode. So first step would be to declare two pointer one in the beginning. So that's, pardon for my spelling, and second is going to be in the end. Once you declare that, what you're going to do, we're going to add the elements. We'll add the number in position 1 and number in position last and see if it is meeting the target. If the result of that is greater than target, then reduce second pointer by 1. If sum is less than the target, then increase first pointer by 1. So we have to run this entire steps, maybe not the first steps, from the second step till the fourth step inside a loop, and the condition will be in such that the position I, the first pointer value, will always be less than the second pointer value. Why are we saying that? Let's say we have this example itself. You don't want your pointer 2 to be here, pointer 1 to be here, and the pointer 2 be here. In such case, it has swapped already, and it should not occur. Then it will solve the it doesn't make sense because the efficiency of the code is getting affected. The main idea is that the pointer 1 will move to a certain number, pointer 2 also will move to a certain number, and when an ideal value is met, it stops instead of going to the entire loop again and again inside a for loop. So now let's convert this pseudocode into an understandable Python code. So back to the screen here. So let's pull this. So it's so we'll go to Python. Okay, it was already in Python. Okay. So we have two numbers. So we have sum. In the sum, we have a numbers as an array that is going to be passed, and the output is going to be another array. So first, what we are going to do is we are going to declare two pointers, as we said. I is going to be, let's say, right pointer. Our right pointer, let's say our left pointer equal to 0, and the second one is right pointer equal to length of the list that has been passed, which is basically numbers. Length number minus 1. Why are we doing that? Because Python has a habit of counting everything from 0. So let's say it starts counting. There are 5 elements. That if you apply length function, it's gonna return you 4 because it starts from 0, 1, 2, 3, and 4. That's how it's gonna return. So we need not if you directly pass the length value. The length function returns 5, but when you count in Python, it starts from 0. So we don't want to our pointer to be pointing at a number which is not existing. Let's say there are 5 elements, and the length of the function will give 5. And if you directly pass 5 into the R pointer, and it will not pass on the 5th element, it will say index out of range. So we have to minus it by 1. So we have 2 pointers. We have declared 2 pointers. Now the condition is, as we said, while left pointer is always gonna be less than the right pointer. So this is gonna be the condition. So once we are going in, first we have to see the number of, we need to calculate the sum. Sum is equal to numbers of L pointer plus numbers of right pointer. So they will hold the sum. So let's say if the sum is less than target. If the sum is gonna be, let's declare it as some other name. Let's say some value underscore value. Same over here, sum underscore value. When the sum value is lesser than the target, when the sum value is lesser than the target, then what we are supposed to do? We are supposed to increase the leftmost element by 1. So what we will do? L pointer plus equal to 1. Else if sum underscore value is greater than target. So in such case, what we'll do? R pointer, which means some value is greater, so we have to decrement it. So minus equal to 1. Otherwise, else what we're gonna supposed to return? Sorry. If it is met, else if some underscore value, else if else also we can do else return what we are supposed to return, L pointer comma R pointer. Let's say we run through this loop, but there is only one element in only one element there. In such case, we are supposed to return an empty array. In the sense, when L pointer less than arbitrary, it will not go inside the loop itself. Even in such situation, we have to think of this situation as well. It should return at least an empty array. So we will return an empty. So yeah, so as you can see here, we have developed this code, but the one thing that you have to keep in mind is that here, as I said earlier, Python starts counting an array from 0. Not counting, whenever you go through the list, it starts from 0. The first element is a 0th element. It is called as a 0th element. So if you directly give, let's say, instead of left pointer and right pointer, you in the flow, you just directly pass the Python this values, left pointer and the right pointer. Let's see what the result is. So here you can see 2, 7, 11 and 15, 9, and the output our code has generated is 0 and 1, but the actual output is going to be 1 and 2. So if you see 2 plus 7 is going to be the 9. Naturally, when a human counts, it counts from 1, 2, 3 and 4. So 1 and 2 is going to be the answer. So that is what is expected. But with Python thinks differently. It takes the first element to be 0th element, and this to be the first element, and this to be the second element, and this to be the third element. So what we have to do is, we have to, once you found the values and we are passing on the value as a output, we need to increment both of them by 1, so that the right value, the human value, the what is expected, we will be receiving it as an output. Let's see how it performs. Okay, 2, 7, 11, 15. What expected is 1, 2, and our output is also 1, 2, and all the test cases are satisfied. Let's see about the test. Hopefully it works. Oh yeah. So yes, it has solved it. It has all the test cases has been satisfied. So here is it. I'll share the link of this code in the description of this file, and please do try it out. And in case if you have any doubt or any clarification whatsoever, please feel free to reach out to us. You can even comment down so that we'll be always active and we'll reply to you as soon as possible. Thank you.